And the auxiliary winding lags behind by a certain angle, and the main also. So now let's consider an example where the auxiliary winding phase angle is 22 degrees and the main winding is 35 degrees. Now, what we want is, if that is the main winding, which is 35 degrees, we want to move the auxiliary upwards so that we have a 90-degree phase shift there. And the angle alpha is equal to 90 minus 35 degrees, which leaves us with 55 degrees. Now, the auxiliary winding's impedance is given as 5 plus J 2,2. We want to know what is the capacitor size that we can do this problem. So now, if we look at this, then that is X of the cap of the auxiliary winding, and that is the resistance part, 5. Now we want to know what that angle or that value is. Let's say that is A, O, and B. Now we've got that angle, which is 55 degrees. So if we have 5 there and 55, if we use the tan of 55, which is the opposite over the adjacent, that gives us AO over 5. Therefore, AO is equal to 5 times the tangent of 55 degrees. That gives us a value of 7,14. Now the capacitor has to move that whole part there. So that will be XC of a cap. Now XC is 10 to the power of 6 divided by 2 pi X C. Sorry, C. C of a cap is 2 pi F XC. Now that means it's 10 to the power of 6 divided by 2 times 50 times pi, and XC is 7,14 plus 2,2. And that will give us a value of 340,73 microfarad. And all these problems are done in the same way. First of all, they give you the windings and the angles, and then you have to determine what is the capacitance to cause that shift. And alpha is the phase shift, and that's always 90 minus that of the main winding. Any questions so far? Okay, now let's go to the values of the alternators. Any questions there? If you can do the examples that I gave you, you should be fine. And that will be something similar to that. And then KD, KP, the winding factor, you just remember that's the type of things that are given. Either your Psi, they will give you 36 slots in 360 degrees. That gives us Psi in mechanical degrees. And then Psi electrical is P times the mechanical degrees. P, like so. Or they will say you've got 9 slots per pole. That gives you your slot angle in electrical degrees, and that will be 180 divided by 9, which is 20 degrees. And then remember, G dash is the slots per pole per phase. Or if you use small p, which is pole pairs, that will be 2p times m. And then you've got your formula. KD is sine n psi over 2 and then G dash sine n psi over 2, where n is your harmonic. For the fundamental, frequency, n is 1. Then we get for the third harmonic and the fifth harmonic and so on. And then the same thing for Kp is cos n epsilon over 2. And epsilon is equal to psi coded by 1 slot. And epsilon is equal to 2 psi when it's coded by 2 slots. And then you should be fine for the last exam. Okay, and then I spoke to the guys about the practical. That will be sometime in January. The technician will come to you guys and they will do the practicals there. Any other questions?